Let's take a look at how we TI-84 would work in very much the same residuals on a TI-83 calculator. Residuals relate to regression, so if I have a paired data set, I can first run regression and then we'll take a look at how we can see the residuals that relate to that. To enter the data, of course, we can go to the Stat key and choose the Edit menu, and then I can enter the X values in list 1 and the Y values in list 2. The regression we're going to do is a linear regression, so again, pressing the Stat key and going over to the Calc tab, option 4 is linear regression. And if I run the regression command, list 1 is the default for X and list 2 is the default for Y. I can see the coefficients of the linear regression equation, and because I have the diagnostic turned on, I can also see the correlation coefficient. So our equation, the predicted values for Y are negative 1.46 times X plus 134.2 for Y. Now, to make sense of all this, let's actually look at a graph of the data. So if I go to the Stat Plot menu quickly and turn that on, so it's set up to be a scatter diagram, and it's going to look in list 1 and list 2 where our data is. So I'm going to hit zoom and choose option 9, which is the stat zoom stat, and it'll set up the window so it kind of shows that data. So we can see the linear pattern, and what this regression line is doing, it's claiming to be, and essentially it is, the best fit for all that data. So if I go to y equals and enter this function, negative 1.46x plus 134.2, and back to the graph, I can see, we're essentially representing the general pattern in the data with that line. The residuals are the vertical distances between the graph and the line. So if I hit trace, I can kind of see that. When x equals 30, we have a data value of 96. The predicted value that comes from the line is 90.4. And so the residual there would be 5.6. It would be the difference between the observed value. So we use y like sub I to represent an observed value, and I want to subtract y hat from that. Right, so the difference between, for example, what we just saw, the observed value would be 96, and the predicted value would be 90.4. So we get a residual of 5.6. Well, each of the data points has a residual, and the process of regression in your calculator, they get stored in a special list called resid. And that list we can access from the list menu. Let me go back to the home screen first. So I'm going to quit. I'm going to hit second and then the mode key to get back to the main calculation screen. And then go to the list command and go down to option 8 on this calculator. Some calculators it might be option 7 under the names tab, and I can see the residuals. So this is the list of residuals. If I hit enter, it'll display those values. I can use the arrow keys to look at the different numbers. We see 5.6, the value that we just calculated, is there. A negative residual means that the dot is below the line. So this had a residual of negative 5.8, and a positive residual corresponds to the observed value being above the line, above the predicted value. What's special about this line is that the sum of the squared residuals is the smallest that it could ever possibly be. And so you may be interested in calculating the sum of the squared residuals. So if I go back to the home screen, there's a way to kind of do that within the calculator. I could look at each of these numbers and square them, but it's a little bit kind of nicer maybe to do this calculation within the calculator itself. I can go back to the list command, to the list menu, and there's a special command that adds up the values in a list. So option 5 under the Math tab is the sum command, and so it'll add up all the values in a list. And then I could go back to the list and choose the residual list and add up all the values in that list. Now if I just add up the residuals, because of the way residuals are formed and because of the way the least squares regression line is formed, that's always going to be 0 because the residuals are sort of balanced above and below the line. So what we need to do to kind of make sense of this, we actually work with the sum of the squared residuals. So I'm going to square, adding a little square, adding an exponent after the list. It's going to square each of the values in the list. It's going to raise each value to the second power, and then add up those values. And so we can see that the sum of the squared residuals in this example is 157.6. To be a little bit more hands-on, we can take a look at the actual calculation between list 2, which has the observed y values, and list 1, which has the x values. To get the predicted y values, I would want to apply the regression function, which we have stored as y1. I'd want to apply that to the list. So if I go back to the home screen again, I can enter list 2 on the screen using the second command above 2, and then subtract. I want to subtract the y1 function applied to list 1. The y1 function is under vars, and then under yvars, and then under function. So pressing enter, I get into the y list of the y functions. So I can choose y1. If I add a parenthesis and then list 1, this will subtract the values from list 1 after we apply the function. It's going to subtract those from each value from list 2. So the first value in list 1, we apply the function and subtract it from the first value of list 2. So that creates a new list, which is the same as the list that we just saw a moment ago. So using the residual list is definitely the easier way to go about this process. But if you want to kind of get your hands on it and kind of get your hands on the calculation a little bit more closely, this is what we're doing. We're taking the y values that we observe. For each value of y that we observe, we can take the corresponding x value and plug it into the regression function, and the difference is the residual. So I can actually store that, the store key next to 1, I could store that as list 3, let's say. And then, just like we did a moment ago, I can take the sum, option 5, I can take the sum of list 3 squared, and we'll see that same sum of the squared residuals. What's special about this regression line, like I said before, this is the line that kind of fits the data the best in the sense that it gives us the smallest possible value for the sum of the squared residuals. So let's look at what would happen if I go to the y equals menu and change this line a little bit. So maybe we could make this an 8 instead of a 6, and maybe make this a 1 instead of a 2. And so this will be very close to the same line. If we look at the graph, it looks like it fits the data pretty much in the same way. But now if I look at the sum of the squared residuals, so if I generate the residuals in this way, for this new line, I can see those different values, and then I stored them in list 3 again, so now I can go and look at the sum of list 3 squared, and we see that we definitely get a slightly higher value for the sum of the squared residuals. So even though the line looks pretty good, the distances, the vertical distances between the data points and this new line are not as good as the best fit line that we can find using the regression command. I hope you enjoyed the video. Thanks for watching.